Good morning to everyone present here. I'm Sangeeta Lakshmi, working as Assistant Professor in EC Department at R.M.K College of Engineering and Technology. So today we are going to discuss about the FPGA architecture and its applications, Unit 3 Building Blocks of FPGAs and CPLDs. So we are going to discuss about the commercially available FPGAs. The second one is first one is actual FPGA we have discussed in the last session, and this session is dedicated for the Xilinx FPGA. See, in Xilinx FPGA it uses the SRAM based system. Okay, um, it that is in whereas in actual FPGA it is based on the multiplexer, whereas in Xilinx FPGA it uses the SRAM based, that is memory based. It is based on SRAM cell, right? See here we have the as usual in FPGA we have three components. One is programmable logic cell, and second one is um, logic cell. Second one is programmable wire, and third one is IO block, right? So the programmable logic cell, which we are calling in the actual FPGA, are called as the logic module. Whereas in Xilinx FPGA, we can call this programmable logic cell as a CLB, right? So we can call that CLB. CLB is nothing but the configurable logic block. Configurable logic block, right? This is the basic unit cell which is present in Xilinx FPGA. See, in between the CLBs, this red color square box is nothing but the programmable switch matrix or programmable interconnect, right? So, by using this programmable interconnect only, we can make the connection between any two CLBs. Inside the CLB, what we have here is, see here, in CLB we have lookup table, flip-flop as well as mux. Okay. Inside this lookup table, what we have is, it is based on the SRAM, I already told you. Here we have the input side is we have the SRAM cell, right? It is multiplexer. The multiplexer will select any one of the input based upon the control signal, right? It will provide the only one data. See how it is programming is, please see here. It will have the multiplexer, right, with memory, right? So this is nothing but the lookup table. In this lookup table, we have the four inputs, no? So we need two control signals. For example, this lookup table can be reprogrammed by using XOR function means. For example, XOR means input A and B, output is Y. So combinations of inputs are 0, 0, 0, 1, 1, 0 as well as 1, 1. You know that very well about the XOR operation. If both the inputs are different, you will be having output as 1. If both the inputs are same, you will be having the output of 0. Right? So this 0, 1, 1, 0 will be stored here. I will write here. See here, I will write 0. It is 1. It is also 1. It is 0. So the input signal A here and B, both are act as a control signal. If my control signal is 0, 0, this 0 will be connected at the output side. Suppose my control signal is 0, 1, this 1 will be connected to the output side. Right? 1, 0 means the third SRAM cell provides the data at the output, and the 1, 1 condition, the fourth SRAM cell provides the output at output. Okay. So this is the way we can program this LUT for any kind of function. So this is the XOR operation. For example, if you want to program this as the AND gate means, see here, we are having the inputs of 0, 0, 0, 1, 1, 0, 1, 1. So what is the output of AND gate is, you know that 0, 0, 0, 1, right? If both the inputs are 1, that time only you will be having the output is 1 for the AND operation. So in this lookup table, you have to store here, I will draw the again the multiplexer, 1, 2, 3, right? Here is the output. Two control signals, it is A and B. See here, if you want to program this LUT as the AND, it has to perform the AND operation, means I have to store this data, that is 0001. It is stored in the SRAM cell. See here, I will store here 0001. Control signal is A and B, right? If it is 00, the inputs are 00, my output is connected to the first SRAM cell. If it is 01 means it will store the second one. 10 means it will take the third data. 11 means it take the fourth data. So this is the way we can reprogram any kind of function by using lookup table. Okay. So this is the example for the configurable logic block, that is in XC4000 series. They have used this kind of CLB architecture. See here, the CLB configurable logic block uses the three lookup tables. It is lookup table 1, lookup table 2, it is lookup table 3, right? So here first lookup table having the 4 inputs starting from G1 to G4. Similarly, lookup table 2 uses the 4 inputs from F1 to F4. Okay, this is the lookup table 1, it is lookup table 2. Lookup table 3 uses the 3 inputs. That 3 inputs is, if I am taking the G dash is my output of first lookup table, and F dash is nothing but the output of the second lookup table. So the third lookup table having the 3 inputs, one is G dash, second one is F dash, and third one is we are taking from the data from outside, right? This is the data coming from the outside. So the lookup table having 3 inputs. So here 4 input 4 input lookup table we have, and 3 input lookup table we have, right? See, for this lookup table, the inputs are G1 to G4. The inputs are G1 to G4, whereas output is nothing but the G dash, right? And another lookup table is F1 to F4, and output is F dash. 3 input lookup table having 3 input, that is G dash, F dash, as well as one data from the outside, that is any C1, C2, C3, C4 we have another extra inputs. So any one can be used to take the data from the outside. Okay. So in this CLB, you have the clock signal. This clock signal is connected to the 2 flip-flops, right? So in the total CLB, how many inputs we have is, this is 4, and here 4. This clock is 1, totally 9, and here also 4. So totally the CLB having 13 inputs, right? How many outputs means totally it has 4 outputs. Okay. See here, these all the marks are called programmable marks. These all the marks are programmable marks. The output from the first lookup table is given to this marks 1. In this marks we have 4 inputs. One is from here, G dash is connected to here. Similarly, the output from the L3, that is the third lookup table, also given here. This is the third output, right? And then another input is F dash. So here you can see G dash, F dash, as well as the output of the third lookup table, we can call it as H dash. So we have 3 inputs. One more input is coming from the data selector, right? So it is 4:1 marks. Similarly here also, if the 4 input, one is G dash, H dash, F dash, and another one is input from the selector. Okay. See, if we are taking the output directly from this marks, this marks is 2:1 marks. In this marks, 2 inputs are, one is H dash, another one is G dash. Here we have H dash as well as G dash. Here in this mux having one input is H dash, another one is F dash. So if we are taking the output directly G and F, this is called combinational output. The G and F are called as combinational output, whereas Q2 and Q1 we are taking through the flip-flop. So the Q1 and Q2 both are sequential output. Clear? So this XC4000 CLB architecture consists of 13 inputs, 4 outputs, 3 lookup tables, right, and 2 flip-flops. So this can be reconfigured as any combinational circuit or sequential circuit. Even a single flip-flop also we can configure the CLB. Okay, right? So suppose if you want to make D flip-flop means we can use the input data D from any one of the inputs from C1 to C4, right? So if you are giving the input D through any one of the C1 to C4 inputs, the CLB, whole CLB can act as a one flip-flop. So this is the way we can program any kind of CLBs to reconfigure according to your expression, that is Boolean functions. Thank you. We have discussed about how we can reconfigure our Xilinx FPGA and what is the programmable logic cell present in FPGA, that is CLB, everything we have seen. One example XC4000 CLB architecture also we have seen, right? So the next is just you can see the comparison between RTX, Kintex and Vertex. Vertex is the high performance FPGA. It is the advanced version. It consumes low power, but RTX is the consume lowest power when compared to all other. But performance wise, Vertex is the best one because the number of logic cells present in the Vertex 7 is, we can see here it is 1955K, right? 1955K means, so this much logic cells are available in the Vertex. That means any complex function we can design by using this Vertex 7 FPGA. The block RAM size is 84 MB. See, when compared to RTX and Kintex, the Vertex 7 having the highest memory, that is 84 MB, right? The DSP slice, why we are using this DSP slice in FPGA? If you want to configure this FPGA as any that is, if you want to perform any signal processing function, we can use this DSP slices. So it uses it having the MAC unit, right? Multiplier and accumulator unit, which can speed up the operation, right? So the FPGA contains the 5280 DSP slices in the Vertex, whereas in Kintex it is 1920, whereas in RTX it having 1040. And the performance of this DSP is 6737 Gmax, right? It is the highest one compared to all others. That's why the Vertex 7 having high performance. High performance, we can say high performance FPGA. How many number of transceivers are available in the Vertex 7 is 96 transceivers are available. The speed of the transceiver is 28.05 gigabits per second. Right? The bandwidth, serial bandwidth also 2784 gigabits per second. Right? The interface is, we are using X8 Gen 3, and memory interface is, it uses 1866 megabits per second. How many IO pins are available means 1200 pins are available. With the operating voltage is maximum of 3.3, right? And the package option, it is high performance chip, right? Whereas in RTX is low cost wire bond lidless flip chip, and Kintex is the low cost. It is also high performance. When compared to 3, Vertex is the highest performance chip. So with this comparison, I'm completing this the second commercially available FPGA, that is Xilinx FPGA. Thank you.